Welcome, everyone, to TechDaily.ai. I'm your host, David, and I'm joined by our expert guest, Sophia.
Hey everyone, really excited to dig into things today.
You can sponsor this podcast for just $25. Your message will be featured across major platforms like Apple Podcasts, Amazon Music, Spotify, and more. If you're interested, visit TechDaily.ai to get started today.
Yeah, that is honestly such a great deal for anyone listening out there.
It really is. So jumping right in, we have a pretty staggering topic for today's show.
Oh, absolutely mind-blowing, really.
Right. So South Korea is preparing to spend like $650 billion, which is it's a figure that totally eclipses the entire gross domestic product of countries like Sweden or Argentina.
Yeah, it's a monumental amount of capital.
And it's all just to own the cold, physical reality of artificial intelligence. Because, when most of us picture AI or the internet, we imagine something entirely invisible, right?
Oh, totally. We just think of the cloud.
Exactly. We think in terms of weightless code floating around in this nebulous digital space. But today, our mission for you listening is to explore what happens when that ethereal technology just slams into concrete, steel, and electrical grids.
It's a huge reality check, honestly.
It really is. We are going to unpack exactly what an investment of this massive scale actually entails, why the geographical shift of these facilities is a total game changer, and how it all ripples across this increasingly chaotic global tech landscape.
Because it is a radical departure from the narrative we usually hear. We spend so much time discussing software algorithms and prompt engineering.
Well, the software gets all the hype.
Right, and the neural network architecture. We completely lose sight of the actual thermodynamics required to run them. The physical footprint here is going to permanently rewrite an entire nation's industrial geography.
Okay, let's unpack this, because the numbers we are looking at are, frankly, difficult to process.
They really are. It's almost hard to visualize.
So, South Korean President Lee Jae-myung recently made this major televised announcement, and he didn't do it alone.
No, he brought out the heavy hitters for this one.
He really did. He was flanked by the leadership of Samsung Electronics and SK Hynix, which, for you listening, those are the world's two largest memory chip makers.
Absolute titans in the hardware space.
Exactly. And he basically pledged to cement overwhelming industry leadership. Local reports are saying investments could exceed 1,000 trillion won over the coming years.
Which is just a staggering number to even say out loud.
Right. That translates to over 651.41 billion US dollars.
Yeah.
And to put that into perspective for you, this isn't just subsidizing a few tax breaks for some tech parks.
No, not at all.
This is a capital mobilization on the scale of building an entire national economy from absolute scratch.
And having Samsung and SK Hynix flanking the president there, that is the critical signal for anyone analyzing this.
How so? Why is their presence so defining?
Because this is not some speculative bet on, which software company is going to build the most popular chatbot next week.
Right. It's not a software play.
Exactly. It's a declaration of absolute hardware dominance. It's laying down the physical bedrock.
I do want to push back on the sheer scale of that capital, though. Because, $650 billion is wild. And we are seeing incredible advancements in software efficiency right now, aren't we?
We are, yeah. The models are definitely getting leaner in some ways.
Right. Open source models getting smaller. They require less compute to achieve the same results we saw from massive models just a year ago.
That is very true. The optimization is moving fast.
So if the software is rapidly becoming that much more efficient, doesn't a $650 billion hardware bet run the risk of becoming obsolete? Is South Korea essentially paving a massive, extensive highway for cars that might figure out how to fly tomorrow?
That is such a compelling counter-argument, and it's one you hear a lot in tech circles. But it really overlooks a fundamental engineering bottleneck.
Okay, what kind of bottleneck?
It's known as the memory wall. So in AI development, particularly with these large language models, the processor itself, the GPU, is incredibly fast.
Right. The GPUs are doing the heavy lifting.
Exactly. But the problem is that it processes data way faster than the memory can actually feed it to the processor.
Oh, I see. So it creates a traffic jam inside the hardware.
Yes, a massive traffic jam. And high bandwidth memory, or HBM, is the only way to break through that wall. And guess who dominates HBM?
Let me guess, SK Hynix and Samsung.
You got it. So even if the algorithms become highly efficient, the overall global demand for AI processing is just compounding. People are running it on millions of devices simultaneously.
So the efficiency gains in the software are basically swallowed up by the sheer volume of users.
Precisely. It vastly outpaces those efficiency gains. You cannot generate a single AI image or run a single predictive algorithm without that data passing through physical silicon.
Which makes sense. There is no cloud without the ground, right?
Exactly. By placing Samsung and SK Hynix at the center of this, South Korea is declaring they intend to monopolize the actual physical bottlenecks, the ones that the entire global software industry is fundamentally constrained by.
Okay, which brings us to how they actually plan to build out this monopoly. During the announcement, President Lee used a very specific phrase.
Yeah, I remember this. It was a very pointed statement.
He said, "We must secure the core elements of AI faster than any other country." And then he laid out what he called the triple axis for this great leap forward.
The triple axis, it sounds like something out of a sci-fi novel.
It really does. So he said this axis consists of semiconductors, physical AI, and AI data centers. So what does this all mean?
It's actually a brilliant way to structure it.
Because for you listening, I mean, we generally know what semiconductors and data centers are, but what exactly separates physical AI from, the digital assistants we already use on our phones?
What's fascinating here is the sheer vertical integration of that vision. The triple axis isn't just a list of 3 random tech sectors.
Right, it's more connected than that.
It's an end-to-end blueprint. It's like the central nervous system of the future global economy. Let's look at the components.
Okay, lay it out for us.
So the first axis, the semiconductors, those are the synaptic pathways, the memory chips we just discussed.
Got it, the pathways for the data.
Right. Then you jump to the third axis, the AI data centers. Those serve as the massive cognitive brain doing all the heavy computational lifting.
Okay, so if the chips are the pathways and the data centers are the brain, that leaves the second axis. Physical AI is what, like the muscle movement?
Precisely. It is the muscle. Physical AI moves the computation off of your laptop screen and into 3-dimensional space.
Oh, wow. So we are talking about robots.
Advanced robotics, yeah. Autonomous logistics networks, smart manufacturing grids. It's AI that actually manipulates the physical world in real time.
So it's not just a chatbot giving you a recipe.
No, imagine an automated factory. The robotic arms aren't just following rigid, pre-programmed code. They are running local AI models to adapt to assembly defects on the fly.
Without having to wait for instructions from some distant server.
Exactly. They don't have to ping a cloud server halfway across the world. The intelligence is localized and physical.
So the South Korean strategy is to just own that entire physical life cycle.
From dirt to deployment, basically.
You design the semiconductor, you install it into the physical AI robotics, and you process the overarching network data in your own massive server farms.
It's an incredible closed loop.
It's like everyone else in the world is trying to patent a specific digital thought. But South Korea wants to own the brain tissue, the nerves, and the muscles that allow that thought to exist in the first place.
That's a great way to put it. And if you control that entire pipeline, you dictate the terms of the global economy. You are capturing the value at every single stage.
But, to power that central nervous system, you need a cardiovascular system, right? You need electricity.
Oh, massive amounts of it. The power requirements are insane.
And here's where it gets really interesting. Because the ultimate limiting factor in the AI race isn't actually the silicon at all. It's the electrical grid.
Yes, the grid is the true bottleneck.
We are seeing AI development quite literally redraw the geographic map of an entire nation right now.
If we connect this to the bigger picture, the energy mathematics of artificial intelligence are just brutal.
Brutal how? Like, give us a sense of the scale.
Well, a single query to a generative AI model, just asking it to write an email or something, can consume nearly 10 times the electricity of a traditional internet search.
10 times, just for one prompt.
Yeah. Now scale that up to a global enterprise level, millions of queries a second. You're no longer talking about just plugging a few extra servers into the wall.
Right, you'd blow the breakers immediately.
Exactly. You are talking about requiring dedicated gigawatt-level power plants just for these data centers.
Which completely explains the massive geographical shift we're seeing in this South Korean megaproject.
Sure.
Because traditionally, the Seoul metropolitan area has been the hyper-concentrated hub for everything, right?
Oh, yeah. Tech, finance, culture. Seoul is the absolute center of gravity in South Korea.
But under this new initiative, they are moving away from the capital. The southwestern city of Gwangju and the South Jeolla province are designated as the new homes for these massive chip production clusters.
Which is a huge deal politically and economically.
It's massive. The investment numbers alone for that area are staggering.
Yeah.
These southwestern regions are earmarked for 520 trillion won. That is roughly $336.70 billion.
That is more than half of the total estimated capital going to a region far outside the traditional capital.
Right. So why there? Why move hundreds of billions of dollars away from Seoul?
Because the Seoul metropolitan area simply cannot absorb the power grid demands of next-generation AI. It's a matter of sheer physical constraints.
They just don't have the juice.
Exactly. But the southwestern regions like South Jeolla possess rich, untapped power resources. Specifically, they have renewable and nuclear generation capacities that actually have the headroom to feed these incredibly power-hungry facilities.
Okay, the power makes sense. But I have to wonder about the human capital side of this, though.
The talent migration issue.
Yeah. You can't just drop a $300 billion techno-city in a rural province and expect all these top-tier AI engineers and executives to seamlessly relocate from Seoul.
No, people like their amenities.
Right. The brain drain into capital cities is a massive issue globally for a reason. People want the culture, the restaurants, the social scene of the metropolis. Doesn't this geographical mandate introduce massive friction into hiring the actual talent they need?
You're definitely right that talent migration is always the primary friction point when you try to do regional revitalization. But we have to look at the sheer gravity of what is being built here.
Meaning the scale makes it irresistible.
Yeah, they aren't just opening some small satellite office in the suburbs. They are building the foundational infrastructure of the next economic era.
Which honestly reveals a pretty fascinating socioeconomic strategy by the government.
It really does. Because South Korea, much like a lot of developed nations, suffers from severe regional economic disparity.
The capital just sucks all the oxygen out of the room.
Exactly. It pulls in the talent and the investment, leaving regional areas economically stagnant. But by using the intense power demands of AI as the catalyst, President Lee is fulfilling a broader political mandate.
He's using tech to narrow those regional disparities.
Yes, you are basically forcing high-paying engineering sectors, massive construction contracts, and generational wealth into areas that desperately need it, simply because that is where the electricity is.
So the electrical demands of AI are effectively doing what decades of standard political policy couldn't do. It's forcing a redistribution of national wealth and talent.
It's a really brilliant way to approach a national infrastructure rollout, honestly.
It is. But I want to hold this highly structured, very physical strategy up to the light of the broader global tech market. Because, the contrast is kind of jarring right now.
Jarring is a good word for it.
When you look at the rest of the world, the AI software market looks incredibly chaotic. It's speculative and highly volatile.
The contrast couldn't be sharper, really. While South Korea is out there pouring concrete and building power plants, the global software markets are struggling to find a solid footing.
Just looking at the recent financial movements, we are seeing serious anxiety. Like Japan's Nikkei index recently closed 4% lower.
Yeah, that was a huge drop.
And it was largely driven by the tech giant SoftBank basically tanking. And that drop was tied to reports that the highly anticipated OpenAI IPO might be significantly delayed.
Which signals a very serious gap between the technological hype and actual market readiness.
Right. And beyond the public markets, there are these stark reports indicating that while AI models themselves are incredibly advanced, legacy corporate infrastructure is woefully unprepared to integrate them safely.
Oh, the enterprise rollout is a mess right now.
Analysts are estimating that over $143 billion is currently at risk globally, just because companies are buying AI tools they fundamentally cannot deploy.
This raises an important question about where the real value lies right now. The public markets are finally waking up to the fact that demonstrating a cool language model is very, very different from creating a profitable enterprise business.
And why exactly is that $143 billion at risk?
No.
Is the software just not doing what it promises?
The software works, but it requires pristine, structured data to operate safely, and most global corporations do not have that.
Right. Their data is a mess.
Exactly.
Yeah.
Their internal data is scattered across legacy servers, siloed cloud environments, disorganized data lakes. If you plug a powerful AI into a chaotic internal network, you don't get magic enterprise efficiency.
What do you get instead?
You get data leaks. You get hallucinations, massive security vulnerabilities. These organizations simply lack the internal data plumbing to use the tools they are rushing to purchase.
Wow. And while these corporations are struggling with their internal plumbing, bad actors are moving at lightning speed.
Oh, the security side is terrifying.
We are seeing reports that everyday customers, armed with generative AI tools, are now rivaling organized criminal syndicates when it comes to e-commerce fraud.
It's the total democratization of attack vectors. AI has lowered the technical barrier to entry for complex frauds so much.
So anyone can be a hacker now.
Basically, you no longer need to be a sophisticated programmer to launch a massive phishing campaign or generate deepfake authorization requests. A commercially available AI can just write the scripts and automate the attacks for you.
So given all of this, the delayed IPOs, the $143 billion at risk due to corporate unpreparedness, the exploding rates of automated fraud, I have to ask, is South Korea's massive physical infrastructure bet essentially a shield against all this software volatility?
That is the exact strategic calculation they are making.
Are they deliberately stepping out of the software casino and instead choosing to just own the building the casino operates in?
Yes, absolutely. The global AI software landscape is speculative and incredibly fragile right now. A massive tech company can release a dominant algorithm on a Tuesday, right?
Right, and it's front page news.
But then by Friday, an open source collective might release a more efficient model that renders the Tuesday algorithm entirely obsolete. Software can be replicated, code can be optimized.
But you cannot download a high bandwidth memory chip.
Exactly. And you cannot open source a gigawatt electrical grid.
It fundamentally changes the risk profile for a national economy.
Mm.
You don't have to bet on whether OpenAI, Anthropic, or some totally unknown startup will win the software wars.
It doesn't matter who runs the winning algorithm, because whoever it is, they are going to need the hardware and the data centers built in South Jeolla.
That is such a safe, incredibly lucrative position to be in.
I really encourage everyone listening to critically evaluate how infrastructure transitions operate historically, because we are seeing a parallel move in the Middle East right now, too.
Oh, really? What's happening there?
Massive capital is being deployed toward grid modernization and physical infrastructure specifically to attract AI data centers. Nations that understand the physical limitations of technology are moving aggressively to own those limitations.
Because if an enterprise software company goes bankrupt because they couldn't figure out their internal data structures, the South Korean manufacturer who sold them the memory chips doesn't take the loss.
Nope. They already got paid. They shipped the product.
And the data center that was built to train that bankrupt company's models, that will simply be leased to the next venture capital-backed startup waiting in line.
Exactly. The software layer of artificial intelligence will constantly evolve, reshape itself, and experience massive boom and bust cycles. That's just the nature of software.
But the underlying demand for compute power, for memory storage, and for electrical energy, that is really going in one direction.
Straight up. It totally reframes how we should consume technology news, honestly.
It really does. We get so easily mesmerized by the magic of the software, like seeing an AI generate an award-winning video from a simple text prompt.
Or synthesizing a completely new chemical compound. It feels like magic.
It does. And because it feels like magic, we completely ignore the massive industrial complex required to make that magic actually happen.
And building that complex requires a level of coordination that very few sovereign entities can manage. You are aligning the world's most advanced semiconductor manufacturing, over $500 billion in capital, and a complete reimagining of the national power grid into a single, cohesive strategy.
It is industrial nation building on a scale that forces us to redefine what the tech sector even is.
Absolutely.
The scale is just breathtaking.
Yeah.
So let's briefly recap the staggering journey we've just taken today. We started with a commitment that defies standard economic metrics. A $650 billion pledge by South Korea to cement absolute hardware dominance.
A monumental bet.
We broke down the triple axis strategy, understanding that controlling semiconductors, physical AI, and data centers means controlling the entire sensory and cognitive pipeline of the future economy.
The brain, the nerves, and the muscle.
Right. We unpacked how the sheer thermodynamic reality of these systems is forcing a massive shift in economic geography. It's moving wealth and talent toward the untapped power grids of the Southwest.
Solving regional inequality with server farms.
And finally, we saw how anchoring a nation in the physical constraints of technology provides a vital defensive shield against the chaotic, speculative volatility of the global software market.
It serves as a stark reminder that the digital future will not be dictated solely by who writes the most elegant code. The digital future is ultimately bound by physical realities.
Exactly. It's about who controls the land, who generates the electrical capacity, and who commands the manufacturing floors.
That's where the real power is.
Which leaves us with a final lingering thought for you to mull over as you watch this space evolve. For decades, we have treated the tech industry as something ethereal, right? A weightless entity living purely in data streams and Wi-Fi signals.
Out of sight, out of mind.
But as nations begin spending hundreds of billions of dollars to redesign their actual physical landscapes, diverting rivers for data center cooling, and rebuilding power grids just to feed the processing demands, we have to ask, is AI still just a digital tool we use? Or is it rapidly becoming the supreme architect of our physical world? Thank you for joining our exploration today, and we'll see you next time.